All right, so we're going to find the slope of a line. That goes through 2 points. All right. So normally we started doing this as, okay, here's a graph. Okay, can you count up and over? Okay, well, you won't always have a graph. So the equation we use is y2 minus y1 divided by x2 over x1, which may look a little complicated at first, but I assure you it is not. Okay, so let's say we're asked to find the equation of a line that goes through these 2 points. Okay, well, we are just going to basically label these since this is our first x value. This is our x1. This is our our first y value, so we call it y1. And then the second point, we have x2 and y2. Okay, so really you're just taking your first x value, your first y value, and vice versa with the second one, x2 and y2. Okay, so y2 we said was 7. Y1 was 5, so 7 minus 5. X2 is 3. And X1 is 6. So we got 7 minus 5 is 2. 3 minus 6 is -3. So we have a slope of -2/3. Okay, and this is just to show you that it's the same as when you have them graphed. Okay, going from one point to the next, I went down 2 over 3. So I get the same slope. All right, so even if you were given 2 points, Okay, the reason we would want to be able to use this if the numbers were really big and we didn't want to have to graph it and count all that stuff onto the graph. Okay, so it's helpful to know the equation that goes into finding the slope of a line. All right, so try those two on your own. Okay, using the equation, don't graph them, just use the equation. Okay, I'll give you a couple minutes here. All righty. So again, sometimes it helps to label it. So here's our first x value. Here's our first y value. Here's x2. Here's y2. So again, we're using the formula y2 minus y1 over x2 minus x1. So I should get 11 minus 15 over 2 minus 4, which would be negative 4 over negative 2, which would then give me a slope of positive 2. Okay, second one again, x1, y1, x2, y2. We get 83 minus 86, and I get 34 minus 28. So I get negative 3 over 6, negative 1/2. Yes, no, maybe. They're mowing the grass outside my room. Can you guys all hear that or no? A little bit.
Yeah, a little bit.
I don't think I have a solution for that, unfortunately. So we'll just tough it out. I'm sure they'll be done soon. Alrighty, so what we're gonna do next, very exciting. The big race. So this is section 2.2.2. Okay. So basically they give you a scenario, okay, and they're asking you to kind of work on ways to try and figure out who wins this tricycle race. So it's 2-52 if you want to follow along in your book. So it says, in the first heat, Leslie, Kristen, and Evie rode tricycles toward the finish line. Leslie began at the starting line and rode at a constant rate of 2 meters every second. Kristen got an 8-meter head start and rode 2 meters every 5 seconds. Evie rode 5 meters every 4 seconds to get a 6-meter head start. Okay, obviously that was a lot of information. Okay, I will simplify it here in a little bit. Okay, but essentially what they're asking you to do here is graph the information of the big race. Okay, so it says on a neatly scaled axis, graph, then write the equation in terms of x and y and the distance for Leslie travels. X represents the time, so our x axis is going to represent time. Our y-axis is going to represent distance. All right, so again, we'll start with Leslie. She was the first one, right? Yeah. Leslie starts at the starting line. And goes 2 meters every second. Okay. So if she starts at the starting line, how far has she gone in 0 seconds? Well, she's gone 0 distance. Okay. So essentially she's starting right there. Okay. Then it also says she goes 2 meters every second. So this is our distance in meters. This is our time in seconds. So for every second that passes, she goes 2 meters. 2 seconds go by, or another second goes by, she goes 2 more meters, so on and so forth. Let's get rid of that. Okay, so this is Leslie's line that shows how far she's gone. All right. So I'll have you, we'll just do them all together. So it's kind of tough. I don't want you to screw it up. All right, next one is Kristen. I don't like that color. Okay, so it says Kristen got an 8-meter head start. And goes 2 meters every 5 seconds. All right, so if she has an 8-meter head start, okay, after 0 seconds, how far has she gone? Well, she's gone 8 meters because that's the head start she gets. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so she's starting right there. And then she goes 2 meters every 5 seconds. So we go up 2 meters, over 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. Okay, so she's going 2 meters every 5 seconds, like so. All right, that's Kristen. And then Evie, the third person. Evie got a 6 meter head start. Okay, and is going 5 meters every 4 seconds. Okay, so she starts here at 6. She's going 1, 2, 3, 4, 5 meters every 1, 2, 3, 4 seconds. 1, 2, 3, 4, 5. 1, 2, 3, 4. All right. Neat, right? Well, now what do we do with this information? So part B says, there's a bunch of questions that kind of follow up. Part B says, after how many seconds did Leslie catch up to Evie? So Leslie's in red, Evie's in blue. So right here is where they caught up to each other, where Leslie catches up to Evie, and that would be after 1, 2, 3, 4, 5, 6, 7, 8 seconds. Okay, but the big question is, part C says, if the race is 20 meters long, okay, who won? Okay, so if we go to the distance, we can count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I should have done this on a new sheet of paper. I'm not smart sometimes. All right, so if you didn't know, how to determine the winner of a race. It's whoever goes the whole distance in the shortest amount of time. Okay, so here up top, this is the 20-meter mark. Okay, and we want to obviously take the least amount of time possible. So if we take a look, we want to find out who gets to that 20-meter mark the furthest to the left. In this case, it would be Leslie. Okay, she does it right there. Evie is pretty close behind her. Kristen is drunk at the wheel and taking way too long to get there. Okay, so it looks like Leslie's going to win. Okay, Evie is going to be just a little bit behind. Okay, it asks you how long does it take each person to finish. Well, I don't know. Leslie looks like she takes her 10 seconds. Evie, I don't know, 11 and a half. Kind of hard to tell, but we'll figure that out here in a second. Okay. So that was heat one. I know what you're thinking. You're sitting there thinking, Anderson, I got to find out who wins heat two because this stuff is amazing. Well, hold on. We'll get there. All right, so we'll look, this is heat two, same thing. We're gonna go time in seconds, distance in meters for X and Y axis. Okay, so now we got Elizabeth. You know what I'm gonna do? Let's see. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20. Make my finish line up here. Okay, so it says we're gonna do first. So we're gonna do Casey, K, and it's just K. All right. Okay, it says K's race is graphed by the equation f of x equals 2/3 x plus 1. Okay, so this is kind of where now we're taking the problem in a word problem, we're taking a look at it as an equation, okay, and kind of going from there. So in the context of this problem, okay, the plus 1 would signify that she gets a 1 meter head start. So that's our y-axis, okay, our y-intercept right there at 1. And then the 2/3 would represent her slope, meaning she's going up 2 every 3. So she goes 2 meters every 3 seconds. 1, 2, 1, 2, 3. Like so. Okay, next up is Elizabeth. Her equation is 12/16 x plus 4 . Okay, so 12/16 can also be reduced down to just 3/4. I'm gonna do that so I don't have to count as much. But again, the 4 is gonna be our starting point. 1, 2, 3, 4. Okay, she's gonna go 3 meters every 4 seconds. Like so. And then the third one, Hannah, says her shoe came untied. Okay, and so she had to go really slow. So it just gives you some points. It says Hannah says at 14 seconds she had gone 10 meters. At 28 seconds she had gone 14 meters. 42 seconds, 18 meters. Okay, so we can plot that first point fairly easily. 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so there's that point right there. Okay, if we were going to count up to 28 or 14 more seconds. Okay, she's gone 4 more meters. We could graph it. We could also come up with a slope. Okay, so we could say, we could take these points right here and say 14 comma 10 and 28 comma 14. I'm going to find my slope. So 14 minus 10 over 28 minus 14. I'm going to get 4 over 14 or 2/7. Okay, a little less work. Maybe it's the same. I don't know. But now I know I'm just going to count up 1, 2, 1, 2, 3, 4, 5, 6, 7. So I get her second point there. All right. So again, if we were trying to find out who gets to the finish line first, it should be Elizabeth. Okay. Hannah, I'm not sure ever gets to the finish line. Just kidding. I know she does, but it's gonna take a while. Okay, and then Kay finished somewhere there in the middle. Okay, so we're gonna kind of work more with this in the days to come as far as, okay, can you take an equation and put it onto a graph? Okay, can you be given a situation like on the first page and be able to put it into a graph and then understand the context of it? Okay, that's kind of the big thing there. Okay, questions? All right, we'll stop there for today. Obviously, kind of a lot of information, a lot of stuff. Okay, no exit ticket today, but I think I assigned a whole 5 problems for homework. I know, so many. Did I put it on the daily agenda? I did. Good for me.